We're going to get started here with Chapter 10, our first section of geometry. And there's really a lot of information here in our first two sections, and so we're going to kind of roll through this. I hope some of it's familiar to you. If you've had geometry recently, it will be more than others, but we'll just go from here. So first thing, we're going to roll through just a couple definitions. So a point is going to be represented with a dot. Pretty sure we're all familiar with that. We have a point. Points, it has no length or width. So when we put a point, it's just it's more of a location, tells us where something is. We are going to label points with a capital letter. So this would be point A, we can have point B, C, D, X, Y, doesn't matter, but it's going to be a capital letter when we're working in geometry. If we have 2 points, we can connect those 2 points with a line. So a line just connects 2 points with the shortest distance. And a line is going to extend infinitely in both directions, so it doesn't stop. If we want to talk about a line that stops, we're going to use line segment or ray. So for a line, if I have 2 points, A and B, the line looks like this, goes through them, and we would call this line AB, or we could call this, so we can call it line AB, you could call it line BA, or abbreviated, you might see it with AB and then a line drawn on top of it. So that is our line AB. So point, it has like no dimension, one-dimensional, I guess. Line, we're going to mean 2. A plane we think of as a 3-dimensional surface. So a plane is a flat surface with no boundaries. So you might think about a piece of paper is like a plane, however, it has to have no boundaries. So we're not talking 8.5 by 11, we're talking about it goes on forever in all directions. So planes have no boundaries, they continue. And if I draw a plane over here, we can't we can't put arrows on the edge of this paper, we can't show that it goes on forever. We just have to show it abbreviated, we have to show it cut off a little bit. And planes are also identified with capital letters, so I put a little H there, so we would call this plane H. We won't work a lot with planes, okay? It's just kind of a good thing to know we have them. The other types of lines that we have, so we have a line which extends infinitely in both directions. If you want to talk about a line that doesn't, so a line that stops, we're going to call this is types of lines. We're going to have a line segment. So a line segment, it doesn't extend in either direction. So a line segment AB would look like this. And you could do the same thing we did before, but don't put the arrows on the end. So line segment does not extend in both directions. It extends in neither. A ray extends only in one. So if you think about like a light ray, it starts at the sun and then it comes towards us. So it has a starting point and then goes infinitely in one direction. So it would be something like this. And we can identify it the same way with an arrow. It's important that the arrow indicates which way it's going. So it starts with A, starts here, goes through B, and that is our ray. Next we have angles. And angles are a very key point in geometry. An angle is going to be a union of 2 rays with a common endpoint. And this little picture over here shows an angle. So we have this angle ABC, like this. And it shows a protractor, which is how we measure angles. You won't have to use a protractor in here, but it does show how we measure an angle. We measure angles in degrees. And so this angle, we start with this side. This is our initial side. It goes over here. It ends there. So this angle would be 50 degrees. We have some different parts of our angles. These rays are called sides. And then we call this point B the vertex. So the vertex is kind of where the angle starts, and then it extends from there. And then we can measure angles in degrees. Additionally, we might want to be able to name an angle. So if we have a picture and it has tons of angles going on, we need a way to identify which angle we're talking about. So if this were your angle and you have a point A, point B, and point C, then we could name this angle as angle. Notice I put a little sign, that is a symbol for angle, A, B, C. We could also have like a number in here, maybe there's a 1, in which case we could call this angle 1. Or if there's not a lot going on and you just have this one angle, then you could also call it angle B. So you can name an angle off of its vertex, which is B. You can name an angle with a number if it's labeled with a number. Or you can name an angle with 3 points, A, B, C, making sure that you're going around the angle. But these 3 are all names for that angle. And you'll see them named in lots of different ways. When we're measuring an angle, we're going to measure in degrees. If we tried to measure something, if we think about like an entire circle, if I have a ray like this and I want to measure all the way around, this would be 360 degrees. And another one that we work with a lot is a straight line. So if I go from here to here, that is a 180 degree angle. So we're going to start classifying angles. We have lots of different classifications down here. First, we have acute angles, and an acute angle is going to be any angle that measures less than 90. So maybe a 50 degree angle would be an acute angle. An obtuse angle measures greater than 90 and less than 180. So it's going to look something like this. Ooh, that one's barely obtuse, but we'll go with it, and maybe it's 110 degrees. Okay. The next type of angle we have is a right angle, and right angles measure 90 degrees. So that covers, we've got less than 90, equal to 90, between 90 and 180. Okay, so we're kind of making sure we cover all of them. When we label a right angle, we're going to label it with a little box indicating that it is a right angle and it's 90 degrees. Last one, straight angle, and we don't use this one a lot. We don't use this word a lot, I should say. But it's just like on a straight line. A straight angle is 180 degrees. So those are our 4 different classifications of angles. They measure less than 90, between 90 and 180, equal to 90, or equal to 180. If we have angle pairs, our angle pairs are going to have a big variety of names. Our first one's complementary angles. Complementary just means that they add to 90, where supplementary means that they add to 180. If we have 2 angles that are adding to 90, if I put them together, they're going to form a right angle. So sometimes you'll see complementary angles like this, where you have a right angle, and then maybe it's broken up into 2 parts. And we could say this one's 60 and this one's 30. So if you added them together, you'd get 90. So these 2 angles would be complementary angles. Additionally, if you have the angles drawn separately, they don't have to be next to each other. They could be 2 separate diagrams like this, 2 angles like that. Then this one's 60 and this one's 30. Then those are also complementary. They don't have to be adjacent. They don't have to be next to each other to be complementary. They just have to add to 90 degrees, which 60 plus 30 is 90. 60 plus 30 is 90. For supplementary, same rules apply. They need to add to 180. So you could see them like this, where they're making up a straight line. So this one, I don't know, maybe 60. This one would have to be 120 if those are going to form a straight line. you might see them together. And if you see them like this, these are called a linear pair, because they're forming a straight line, a linear meaning a line, and they add to 180 degrees because they're forming a straight line. Additionally, like complementary angles, they could also be drawn separate, but most of the time we're going to see them side by side, and we call this a linear pair. So let's see how we could apply this. So down below we've got find the measure of angle. When you see an M, that just means measure of. So we want to find the measure of angle DBC. So starts with D, goes to B, and up to C. So we want to find the measure of this angle. Since I see that I have a 90-degree box, I know that these angles together are going to add to 90 degrees. So all I have to do is take 90 minus 62, and that gives me 28 degrees for what's left over. Since these two angles are forming a right angle, since they add to 90 degrees, what would we call them? Well, we call them complementary angles. Complementary. All right, I'm going to flip it over and do the question on the back. Keep in mind you can pause this video at any time, so I know I'm talking kind of fast, but that's because you have the ability to pause and restart as necessary, so please do that. For question 2, we're going to find the measure of this angle, this missing angle. Once again, I see this 90-degree box, so I know that together these two angles are going to make 90 degrees. So all I have to do is 90 minus 25, and that leaves me with 65 for our missing angle. Okay, we got some more angle pairs that we're going to go through. So we're going to go through, we already went through linear pair a little bit, but we'll formalize it, and then we have vertical angles. So if I look at this picture off to the right, I have two lines intersecting. I have this line intersecting with this line and forming a lot of different angles. So we have two different types of angle pairs that come in this type of situation. We're going to have vertical angles and linear pair. Vertical angles are angles that are across from each other when lines intersect. So vertical angles. They are across when lines intersect. And an example of those would be angle 1 and angle 3. So this one and this one are vertical angles. They're across from each other. Same with 2 and 4 would also be called vertical angles. They're across from each other. Linear pairs are angles that are next to each other. So linear pairs form a straight line. So for instance, as an example, maybe angle 1 and angle 4. So these two angles together form a straight line. We have some nice relationships that happen when this occurs. So for vertical angles are always congruent. Which just means they have the same measure. And a linear pair are always supplementary. Meaning that they add to 180 degrees. So since 1 and 4 together form a straight line, we know that these two angle measures are going to add to 180. Additionally, we have like 2 and 4 are going to be the same size, and 1 and 3 are going to be the same size. So if I give you one of these angles, you can find out all of the others. For instance, if I tell you that angle 1 is 50 degrees, then you could say angle 3 is also 50 degrees because they're vertical. And then 2 and 3 are a linear pair. So I know 2 and 3 together, these two, need to add up to 180 degrees. So that makes this one 130. And this one's 130 because these are vertical. So this is our relationship when we have two lines intersecting. The angles across are congruent. The angles next to each other are supplementary. Another situation we can be in is if we have two parallel lines cut with a transversal. So transversal is a line that's going to cross over both of them. So if these lines are parallel, then we get a lot of really nice relationships among the angles. So the first type of angles we're going to have in this diagram are called alternate interior angles. So alternate meaning opposite sides of the transversal, so opposite sides of the transversal, interior meaning between the parallel lines. So I want to be between the parallel lines, so I'm interior, inside here, but I want to be on opposite sides of the transversal. So this is going to be like 3 and 6 or 4 and 5. So I'm going to draw a tiny picture here. Got my parallel lines. It's going to be this angle and this angle are called alternate interior. Pick up another color here, and this one are alternate interior. The next angle relationship we have is alternate exterior. Similar idea, alternate sides of the transversal, but now we want to be on the exterior of the parallel lines. So if I go on the outside of the parallel lines, this one and this one are alternate exterior angles, and then this one and this one are also alternate exterior angles. The third and final relationship is corresponding angles. And corresponding angles are in corresponding or the same location at each of the clusters of angles. So cluster of angles here, cluster of angles there. We want to be in the same location. For instance, number 1 is in the top left. Number 5 is in the top left down here. Number 2 is in the top right. Number 6 is in the top right. So 1 and 5 are corresponding. 2 and 6 are corresponding. 3 and 7 and 4 and 8 are pairs of corresponding angles. So if I just pick out, maybe I'll just pick out 1. So this one and this one are corresponding angles. They're in the same location. When we have these types of angles, these are, if the lines are parallel, these 3 pairs are always congruent. So if lines are parallel, then 1, 2, and 3, those over there are all congruent. Same size. So it's really nice, in this diagram, if you have parallel lines, all the angles are either congruent or supplementary. So for instance, 1 and 4 would be congruent because they're vertical, but 1 and 2 would be supplementary because these are a linear pair. So 2 and 6 would be the same because they're corresponding, but then you also have some that are supplementary. So let's look at this example down here. If I'm given that this angle 8 is 35 degrees, I'm going to try to go in order of numbers. We'll see how that goes. So here's angle 8, it's 35. Angle 1 is also going to be 35 degrees, and that's because these are vertical angles. So we have that the measure of angle 1 equals 35 degrees. If I try to jump to number 2 next, so number 2 is up in the other angle pair cluster. 1 and 2 are related because these are corresponding angles. They're both in the lower right-hand corner of these angle clusters, so we know that they are also congruent. So the measure of angle 2 is also 35. Now if I look at the angle 3, the measure of angle 3, I notice that angle 3 is obtuse. So I'm pretty sure it's not going to also be 35 degrees because this looks to be bigger than 90. So 2 and 3 are forming a linear pair, so 2 and 3 are going to be supplementary. So to find the measure of angle 3, we're going to do 180 minus 35, which gives us 145 degrees, and so angle 3 is 145. So far we've done 1, 2, and 3. I'll label that in my picture. So 3 is 145 degrees. Then angle 3 and angle 4 are related because those are vertical angles, and we know that vertical angles are also congruent. So since 3 is 145, 4 is also 145 degrees because they're vertical angles. If we do angle 5 next, 4 and 5 are forming a straight line together. So these are supplementary, making angle 5 35 degrees. Additionally, these are vertical angles, so you could say they're congruent. These are supplementary. These are congruent. So angle 5 is 35 degrees. Let's see. Let's try to go from, so 5 and 1 are alternate exterior. 6. So 6 and 4 are alternate exterior angles. So you might say, okay, these are congruent because they're alternate exterior. Additionally, you could look at 1 and 6 and see, okay, they're forming a straight line. Either way, we get that the measure of angle 6 is 145, and so is 7. These are vertical angles, so we expect them to be congruent. So measure of angle 6 is 145, and the measure of angle 7. All right, that covers section 10.1. I'm going to stop here. You can go ahead and try the homework, see what you can do, and I'll be adding a second video to go over 10.2.